Hello and welcome to Proving Tautologies or Proofs for Tautologies as you will find it in your book. Now this is another part which we can solve using both indirect proof as well as conditional proof. You can also use SCP for that, but does not matter. Actually, the theory of this is very important. There is a very interesting line in your book which I will like to read for you. And this line says that if the conclusion is a tautology, then the method of deduction permits us to prove that an argument is valid even though it has no premises, either using the rule of conditional proof or using the rule of indirect proof. What does it mean? Like suppose if we go back to the theory of a tautology, so we know that something is a tautology when it is necessarily a true statement, right? Or it is an a priori true statement. Now, let us try to expand our understanding of tautology. We know that tautology is basically a statement, right? It is a statement, fine. It is an a priori statement which is always true, fine. This is one understanding. Tautology is also a rule of replacement, right? Because T wedge T, or say I will not use T because then you can get confused. If I will say P wedge P is equivalent to P, or P dot P is equivalent to P, this is also a tautology. Okay. Now these two understandings of tautology are certain things which has already been introduced to you in this course. There is one more understanding of tautology which has also been introduced to you in this course. However, you may have ignored it, or it may not have grasped your, I will say, mind much, or your understanding, right? So this is to bring your attention to that fact that tautology is also an argument which is a valid argument. Like if you remember, I said that if we have premises P1 up to Pn and the conclusion is C, so P1 conjunction, P2 conjunction, P3 conjunction, up to whatever premises we have, say up to Pn conjunction. If we take this and then implying the conclusion will be a tautology, right? We have explained this thing. We have also discussed this thing a few videos back as well. So tautology is having a lot of understanding. Tautology is a statement, is an a priori statement in fact, which is always true. Tautology is a rule of replacement, like P wedge P is equivalent to P and P dot P is equivalent to P are also tautologies. Tautology is also this understanding. You can call it a statement, for sure you can call it a statement, but it becomes an argument form in itself as well. People may have objection to this, but believe me, it is an argument form in itself. It is a valid argument form in itself, right? And the connection is this, that if you put the premises, the conjunction of the premises implying the conclusion will become a tautology. Now you understand that what is a tautology. Now if you see this, any tautology, like suppose P implies P is a tautology, we know. Or if I write it in another way, it will be like this, because this will be also negation of P wedge P, and I am writing P wedge negation P. Both are tautologies, we know. Now then, if you consider this to be a premise, then this implying the conclusion is a tautology. So this in itself becomes an argument, right? It in itself becomes a valid argument for that matter. Similarly is the case with this. So if there is a tautology, and this is what something which I have explained before, and I told you that maybe we do not have enough of say ammunitions in our arsenal to prove that if the conclusion is a tautology, then the argument is valid. But now I can tell you that if there is a tautological statement, so you do not need premises. This in itself becomes a valid argument form. And this is what we need to prove. And that is what Copy also says, that if you find a tautology in the conclusion, then there is no need for even a premise. Forget about whether the premise is true, whether the premise is false, whether the premise is a contradiction. Does not matter. You have a conclusion, and that is a tautology. It makes it enough, or that in itself is enough for you to understand that this in itself becomes a valid argument. But then you need to prove that something is a tautology. How to prove something as a tautology? This is the idea. Now this, as Kopi says in his book, that you can prove it with the help of CP as well as with the help of IP. Let us see how to prove it. It's pretty simple, in fact, very, very simple. Like suppose if I take a question like this. Prove that this is a tautology using CP. Okay, so we will use CP for proving this question to be a tautology. A implies B implies A dot C implies B dot C. They are asking us that prove that this is a tautology. Now, one way of solving this question is to prepare the truth table and see. Now, you know that this is going to be the main connective, right? So, once you will make the truth table and draw it, you will find that this is a tautology. But then you can prove using CP as well. Now, suppose if this is your premise, or this is something like this is something which you need to prove as this is a tautology. So what you will do, like this is the one question which is given to you, you write 1 and you take this antecedent part, A implies B. Okay, therefore, because this will become A dot C implies B dot C. Now it comes in an argument form, right? So now we can prove this, but you can see that we can apply conditional proof again. So let us apply conditional proof again. A dot C. Okay. Therefore, B dot C. Now you cannot apply more conditional proof. So you have to prove that A implies B, A dot C, therefore B dot C. Now this is something which you have to prove. Now you can see that it's peanuts for you. It's so simple. Line number 3, simplify A. Okay. Line number 4, with this you will get B. So 1, 3, modus ponens. Okay. Now simplify C as well. C. So it's 2, commutation, simplification. Fine. Line number 6. Conjoin these two, B dot C. This is 4, 5, conjunction. And your answer has arrived, right? So it's pretty simple. And there is nothing to worry about. But the idea is that you should know that conditional proof can be used for proving tautologies as well, right? You can also prove it with the use of SCP. That is something which we will be discussing in a later say lecture or in the class or something like that. But if you ask me how to prove a tautology, I will say the most genuine way. I do not know whether I can use most and genuine together because my English is not very good. The best way to prove a tautology will be to prove it as using indirect proof. That means something is given as a tautology. How you will prove that it's a tautology? The negation of that will be a contradiction, right? So let us try to prove it using IP. Now, let us take a question for IP. You have a lot of questions in your book to prove tautologies using IP. So let me take a question from your book for proving something as a tautology using IP. Okay, let us take this question. A implies B, which B implies C. Now this is the question which has been given to us. Let us see whether I do not know whether it's a tautology or not, because there can be questions in our book which says that try to prove that whether it's a tautology. If you cannot prove it, then it's not a tautology, right? So that can also happen. But let us see. It's a simple expression, and let us try that we will put a negation on this. We will put a negation on all of it, right? Now this is given. We will put a negation and try to see if we can reach a contradiction. If the negation of this is going to be a contradiction, then it means that this initially was a tautology, right? This is the understanding, and this is, I will say, as the best way to, because that clarifies every understanding of a tautology, right? So let us try. I will put a big bracket over here, and I will take a negation of this. So in the next step, what I can do is that I will put the negation outside only, and I will write it as negation of A wedge B wedge, negation of B wedge C. Fine. I am using material implication. If I call this as say line number 1, so, or I will just write material implication without using line number as well, because I applied material implication on this line. So I'm just writing it. You can name it. Let me name it as step number 1, so that we are not confused. This is like step number 2. So I write on step number 1 material implication. Okay, fine. Now let us take step number 3. So what I can do, I can put the negation inside using De Morgan's law. So this will become A dot negation B, right? Because as soon as the negation will go, then this will also become a dot, and this will become B dot negation C, right? This will also become, because the negation will work on this as well, because the negation will be here, dot, the negation will be here, and I am applying completely De Morgan's law. So you will find on to De Morgan's law will give this. Fine. Now you can see that negation B is there, and all are conjunctions. So you can very easily take it out. So you can take out negation B from here by writing on 3 commutation, simplification, and you can also take out B from here by writing the same thing, because you have to commute maybe twice, thrice, does not matter, and then you have to simplify. So ultimately you get negation B, you get B, and this is a contradiction, right? So you can write now that B dot negation B. Okay, this is 4-5 conjunction. Now you can write one step here, that this is a contradiction, therefore this expression, not the negation, this expression A implies B, wedge B implies C, is a tautology, right? So here you can leave the question here, because there is nothing to prove apart from that it is a tautology. Now if you have to prove something as a tautology, what you can do, either if you are applying conditional proof, so you can apply conditional proof and see that it becomes like with the help of premises it becomes the conclusion. So that's a normal natural deduction method using rules of inference, rules of replacement, and conditional proof. The other way is to put the negation on the expression and reach a contradiction, because this is a contradiction. We know that B dot negation B, A dot negation of A, or whatever the contradiction expression has reached. So once we have reached this, so we will say that the negation of this, or it will be like A wedge A implies B, wedge B implies C, is a tautology. So these are small things which you can do using conditional proof. You can use IP and so on, but the understanding has to be broadened now. Whenever you call something a tautology, it has a lot of meanings, right? A tautology is an a priori proposition which is true. It is structural, right? Tautology is a rule of replacement where P wedge P is equivalent to P, or P dot P is equivalent to P. That means that it stops us from duplicating the data, because if P wedge P wedge P wedge P wedge P is there, so it's nothing but P. If P dot P dot P dot P dot P dot P is there, so it's nothing but P. So that understanding has to be developed. Then any valid argument, any valid argument is a tautology in itself if you conjoin the premises implying the conclusion will come out to be a tautology. So these understandings has to be there in your mind, and you can make something or you can prove something a tautology if you put negation on that tautology and see whether a contradiction arises, or you use the conditional statement or conditional proof to prove that there is a valid argument. So all these things has to come to your mind, all these things has to be there in your mind, so that you understand that what is a tautology and how to prove that something is a tautology. So this was a simple and small exercise which I wanted to bring to your attention, so that you not only have clarity about what is tautology, but also how to prove something as a tautology apart from using the truth tables. Thank you.